What is up, guys? Fahir here from AwesomeTuts.com, and welcome to a new section where we are going to cover the basics of C#. And I know you are eager and you're very excited to start coding our games because they are awesome. They are just awesome. But we need to go through the basics of C#, and if you go through this whole section, you will understand everything later on in the course, because I'm gonna cover C# deeply like in no other course that I saw so far, and even on the internet, because I see people don't cover inheritance, don't cover what are objects, why do we have some functions in Unity when we open a script, so on and so forth. So I want to cover all that, and then it will be clear to you what we are doing when we start creating our game. So I highly advise you that you go through this section and try to understand everything what is going on. If you don't understand, then you can simply ask a question and I will be there to respond ASAP, or as soon as possible. So I was thinking about, should I create a new project or not? But I'm gonna go into my first game, or our first game, Pumpkins and Golems, that we have created in the first section. So instead of creating a new project using this one, I will be able to explain to you some things that we did here while we are explaining basics of C#, and then you will understand what is going on. So I'm gonna go into the scripts folder and I am gonna create a new folder inside of it, and I'm gonna say intro to C#. So intro to C#, and inside of that folder, I'm gonna create a new C# script by right-clicking, of course, and then go create, and then C# script, and I'm gonna call this one tester, just so that we can, well, test things out. Now, first things first, if I run this script, so I'm gonna run it, it's gonna open here in MonoDevelop. By the way, if you coded in Visual Studio, or you prefer to code in Visual Studio, you can simply go here in Unity, and then you can go in Preferences. This is for Mac. On Windows, I believe it's under Edit, and then Preferences is somewhere around here or here. But either way, you go to Preferences, then you go to External Tools, and then here for the External Script Editor, you can either choose Internal, or you can browse and choose, well, your Visual Studio. So going back here, this is our tester script. As always, I like to do things like this. I like to tag it here with a comment, and we will cover comments in a moment, and give a little bit space. I'm doing just so that we can see what is going on. Maybe let me just try zooming in. No, I think zooming out like this is okay. So the first thing that I want to cover, and that's the basic thing, or the first thing that's always covered when you start learning a programming languages, and that is a programming language, and that is variables. So what are variables? Well, we've seen them before. We use them in our Pumpkin, we use them in our camera follow script. The first variable that I want to introduce is called a float. And we declare variables like this. We first type the type of that variable, then we give it a name, then we give it a value. So the type of the variable is called float, and now we give it a name. Let's say, for example, power. And now we give it a value by typing equals, and now we type the value of that variable. Let's say 2.1, like this. Now, since this is a float, which begins with letter F, we need to add F here at the end to tell the compiler that this is a float. And we will see in a second why. But this is a decimal point variable. A float denotes a decimal point variable. We can either type 2.1. If it's a whole number, for example, like 2, then we can only type 2. I mean, that's like a shortcut. But you can type 2.0 and, well, it will be the same. But like a shortcut, instead of 2.0, you can type 2. And since this is a decimal number, C# or the compiler will automatically count it as a 2.0. But if you want to type, let's say 2.5 or 2.4, then you need to do 0.4, because otherwise C# will not know that, so we need to tell it. So that's it. This is all that it takes to declare a variable. And as I said, first you type the type, and this is a float, then you give it a name. Names for your variables depend on you and solely on you. But when you are creating projects, you want to give meaningful names. Like here, we give it power. And if you go in the Pumpkin script, we gave it move force. Why? Well, because we are using it here to move our pumpkin. So we give it a meaningful name. That's why, or that is the reason when we take a look at our code, we know what that variable is doing. And maybe you're confused. I'm saying when we take a look at our code, we know what the variable is doing. When you're working on the project now, you will know, of course, what the variable is doing. But when you leave that project and don't touch it for 6 months, 1 year, and you come back to it, believe me, you will forget your code. So you want to give meaningful names, and then you will know automatically, okay, when you go back to this project after 1 year and you see move force, okay, well, we use this variable in order to move our body. And we see here, yeah, we use it to move our body. This is what I mean by that. So moving forward, another decimal point variable is called a double. So we declare it like double, and then we give it a name, let's say health, and then we give it a value, and let's say it's 3.5. And we don't need to add F at the end. Maybe you're saying, do we have to add D at the end? We can, but we don't need to do so. Which brings me back to this F right here. If I remove this F and save the script, notice if I go in the Unity editor, what is going to happen here in the console? It says, literal of type double cannot be implicitly converted to type float. Add suffix F to create a literal of this type. Let me just double type this, and it's pointing to our float variable. What does this mean? It means that if we only declare a float like this, we don't type F at the end, so 2.4, C# is now confused because double is also a decimal point number, and we can type here 2.4, and that's a double. But a float is also, as I said, a decimal point number. So how we can differentiate between them, how C# can differentiate between them, is that we add F at the end of a float. So we need to add F at the end of the float, and now when I save it, go back in the Unity editor, the error will go away. Don't worry about these warnings. It's only telling us that we have declared these variables here, but we are not using them anywhere else in our script. But the point is that when we add F at the end of the float, that's how we differentiate between a float and a double, because a double is also a decimal point variable. Now, in my previous courses, my previous tutorials on YouTube, people ask me, okay, this is a decimal point number and this is a decimal point number. They were talking and referring to a float and a double. So what is the difference between them? The difference between them is that a float is a 32-bit number and a double is a 64-bit number. And also, a double is more precise than a float. The other day, I got a comment from a student like, he was talking about variables, it was not clear, I only have understood that a double is more precise than a float. I mean, what is else here to understand? A double is more precise than a float, and a double is a 64-bit number, and a float is a 32-bit number. So a double is precise, let's say up to this number right here. I started typing characters. Up to this number here, and a float is precise, let's say up to this number here. Now this is my rough guess, and I always say this. If you want to know in more detail about the precision of a double, then you should Google that up, and the same way for a float. But this is just to give you a picture what is going on here. So a double is a little bit more precise than a float, and also a double is a 64-bit number and a float is a 32-bit number. Same way as that student understood, but he was complaining about that. There is nothing else to it. Moving forward, these are decimal point numbers. Do we have whole numbers? Yes, we do, and they're called integers. And we declare them like this. We type int, short for integer, and then we give it a value. Let's say score, and it's equal to 44. And of course, on every statement or every declaration that we do, we need to add these semicolons at the end in order to end our statement. If we don't add them like this, then bam, we have a problem. And it's not quite clear. It says unexpected symbol void. If we go here, it's pointing here on the start. But usually when that happens, unexpected symbol that you see here, so when you see unexpected symbol in your console as an error, that usually means that the previous line has no semicolon here to end the statement. In most cases, but sometimes it does not mean, but in most cases it means. So an integer is a whole number. So we type int score is equal to 44. Now we cannot type 44.5. This is not allowed. If we go back here, it is going to complain, cannot convert double to an integer. Are you missing a cast? In short, Unity Editor is telling us you have declared here an integer, but you put here a double. Something wrong with you? No, Unity. Everything is okay. I'm good, bro. So yeah, this is a whole number and that's what it is to it. That's all there is. This is very simple. Don't be scared because I see most people are scared like, do I need math? I don't know. No, don't worry. This is really simple. So int, short for integer, then you give it a name, equals to assign a value, and then you type here a value. Moving forward, we have something called a string, and we type string, string, then we give it a name, which I'm gonna say name, very original, I know, and a string is a character-based or a character variable. What does that mean? Well, we type here characters, but we don't type them like this. If we type it like this is not gonna work. We see a warning here right away. We need to type them between these quotes. So we need to type double quotes and between them, so between the quotes, like this, I'm hoping that I have spelled this correct. Don't judge me. So between the quotes, we type what we want. So for example, we can use the string in order to represent the name of our player. So we can say wizard like this. So string name wizard. String is a variable type, same as a float, double, or integer. Name is the name that we give. So you can give any name that you want. So you can say player name like this. Equal to, then you assign a value. And then you can type anything that you want, but a string needs to be typed between double quote marks. And then you type characters that you want that are meaningful for your game. And the last type of variable that we have is called a boolean. And in short, we type it or declare it bool, which is short for boolean like this. In some programming languages, you need to type boolean. For example, in Java, you will need to type boolean, but it's the same thing. But here you type bool, and this bool variable can only have two values. So I'm going to say here is alive is equal to, and it can either be true like this, or it can be false. So a Boolean variable can either be true or either it can be false. And that is it to it. There is nothing else to this variable. Again, we are declaring these variables using the same approach. So first you type the type of that variable, then you give it a name. And after that, you simply type equal to, and then you assign a value to that variable. And that's all there is to it. Again, Boolean variables can be true or false, and we will use them in conditional statements, which we will cover later on. But conditionals are this. So this right here, let me just see. Yeah, this is a conditional. If transform.position.y is less than -10, this statement right here is going to return a Boolean. That means this will here either be true or false. So either is our position y less than -10 or it is greater than -10. There is no third outcome. And we will see that when we cover conditionals. And the last thing that I want to talk about is this right here that you see. This, what it says, use this for initialization. I don't want to talk about initialization, but this right here that you see, and let me just move it back. This right here that you see is called a comment. Comments are used to document code. And we do that by typing backslash, so 2 backslashes, and then you type what you want. Type whatever you want. Want like this. Not want, man. You can also type it like this. You can say backslash and then asterisk sign. And then you can go back and type asterisk sign and then backslash again. So anything that you type between here. So what you type between the backslashes, so between this and between this, whatever you type here is a comment. Whatever you type between is a comment. Again, comments are used to document your code. Now, don't be confused and go crazy using these comments all around your project. No. So what you're going to do is, or what I do, good code documents itself. So when you type here float power, you don't need to go here and say like this is the power of the player. you don't need to do that. Payer. Not payer, man. It's player. We don't want to be payers. We want to be getters, you know, get the money, not pay the money. So yeah, this is the power of the player. We don't need to do that. Why? Well, because if we take a look at the name of the variable, okay, float power, well, this must be the power of the player and denoting how much power he has when he hits an enemy. We don't need to type a comment like this. But what I usually do is, for example, you can use these comments like here. Use this for initialization, and then you know what this function is doing. For example, if you have another function, and we will cover functions in another lesson, don't worry about that. So you can type above the function like this. Update is called once per frame. For example, we have a function to calculate two numbers. We can say this function is used to calculate two numbers, just so that we know what this function can do. And I also like to denote, for example, that something like this. So start function begins here, and I type then start function ends here, just so that I know where my start function is. And the reason for it is if I have a lot of code here and I type that code, let's say I type the function here and here and here, and the function goes up to here, and I don't see where is the beginning and the end. This is what I like to do. So yeah, you can use it like that, but just don't go and type all of these comments everywhere in your code. Good code documents itself and point or dot, however you want to call it. Anyways, this is it for this video. These are variables, nothing extraordinary, nothing hard. It's very easy, and this is what you are going to use. These 5 types of variables that we have introduced, this is what you're going to use to complete, to put together, to create, to code your game. And this is all there is to it. Again, just briefly before we end the video, I'm going to go through every single variable. So a float is a decimal point variable. We type the decimal point number, and we need to add f at the end. Even though if we type here 2 only, we need to add f at the end, or otherwise we will see the problem that we get. A double is also a decimal point variable. We need to declare it like this. So double, then we give it a name, same as for any variable, and then we give it a value. We don't need to type anything at the end or as a suffix. We can put D here, and if I go here in Unity, it's not gonna complain. Notice here, we don't have any problems with it, but we don't need to do that, because if we don't type, we only type decimal point, Unity or C# is gonna know automatically that this is a double. The difference between the two, again, is a double is a little bit more precise than a float, and it's a 64-bit number, and a float is a 32-bit number, and it is a little less precise. Integer, or short int, is a whole number, and this is how we type it. So int, give it a name, give it a value. We cannot type decimal point numbers here because we will get an error. String is a character-based variable, so we type string, then we give it a name, and then we give it a value between double quotes. So quote, quote, or double quote, and then we give it a value between these quotes. And lastly, a Boolean is a variable, short bool, so we declare it bool, and it's a variable that can either be true or it can be false. So that is all there is to it, guys. Fahir here from awesometuts.com, and I will catch you in the next video. What it is, people? Greetings from Fahir from awesometuts.com, and I want to talk about something that most people who ask me about programming are really scared of, and that is math in programming. Ooh, it's really scary, but in fact it isn't. It's really, really simple. Now I'm gonna erase everything what we did here, because I'm using the same class, which is our public tester, and going to this start method, which we saw here, we use it here. Actually, we use the wake in our pumpkin and in our camera follow. We also use the wake. We will talk about that soon enough. But this start function will be called when we run our game. When I say run our game means when we press play here, the play button right here, all of the scripts that are attached to game objects here in the hierarchy. So for example, this script right here, it will go, or Unity or the compiler or whoever will go inside of those scripts looking for these methods, start, awake, and it will initialize them right away. So start, here we initialize our code, which means that we can test things that we want to do now. And I want to talk, as I said, about math. And that's just basic math. If you've been to kindergarten, if you've been in the first class in your elementary school, then okay, you are a programmer. Just like that. So you know to program. Let's start and see. So let's say I have int a and that is equal to 5, and now I have int b which is equal to 6. If I want to sum them up, I can say int sum is equal to a plus b, and that is that. I can also say a minus b, a multiplied by b, or divide them. But I'm gonna say here plus or leave it at plus. And now we want to see the result. How can we see the result? And by the way, this is that basic math. So this is everything that you need in order to perform mathematical calculations in programming languages. In all other programming languages, this is the same. So you simply type a plus b, or even we can say here 5 plus 6 instead of typing a plus b, if we don't want to declare these variables right here. Now we want to see this when we run our game. And for that, we have this console right here, which gives us a warning that we use these variables. Just ignore it. It's telling us that we have declared them here, but we are not using them anywhere else. We know that, so don't worry. Now we need this console. If you don't have it, you can go under Window and then it's right here at the bottom, console, or Shift Command C, probably Shift Control C on Windows. And here we can print everything from our code. And how can we do that? Well, we can use two methods for it. So we can use print statement, or we can use debug.log. So either of these can do. So if we use debug.log or print, that can do. And what we want to print, or what we want to debug.log in the console, we simply put it between these parentheses. So we want to type sum, or see the outcome of sum. So I'm going to remove debug.log because we don't need it. And when we run our game, it is going to simply type or calculate 5 plus 6, and it is going to print it in the console for us to see. Now going back here, I just mentioned that here in the console, or when Unity runs our game, it will go in every script that is attached to a game object. This is what I mentioned. And what I mean by that, in order for this script to work, to execute, if we run our program now, or if we run the game now, notice nothing is gonna happen. So nothing at all. Why is that? Well, in order for a script to work, we need to create a game object and attach that script on a game object. So please, you can bookmark this. So you will see bookmark at the bottom, in the bottom middle of your video where you are watching, and bookmark this. So what you need to do in order for make a script to work, you can either right click here in the hierarchy panel and click on create empty, or you can go under game object and click on create empty, and here it is. And we're going to call this one tester game object. So this is our tester game object, and now we need to attach our script on it. So we can either drag the script and attach it on him right here. I think we can also attach it like this, so dragging it and releasing it here. Yes, that can work. And we can also go under add component and search for tester. And here it is, and we can hit it, and now it is attached. But we have attached 2. We don't need 2, we only need 1. So now I'm going to click on this gear icon here and remove component, and now we only have 1. So if we run our game now, so if I hit run here, we are going to see 11 printed in the console. And since this is our scene of our game, I don't want to watch these columns every time. I'm simply going to go file, new scene. Okay, save this scene, we don't care. And I'm going to simply resave this one. So let me just go here, asset scenes. Doesn't matter which the name of the scene. I'm going to say tester, and hit save. But we need to again create an empty game object, which I'm gonna call tester. So tester, and I am gonna attach the tester script on him. If I run our app now, or our game, we are gonna see 11 printed here in the console. And if I double tap on it, it's gonna bring me right here. It's gonna bring me to the code that has printed that in the console. Now, if we want to do one thing, which is called string concatenation, that is, combine strings and integers, we need to use the plus sign. So if we want to do something like this, the sum of A and B is, and now we want to add this sum. So if I say here, instead of 5, I say A, and instead of 6, I say B, and I want to print this sum, but also I want to print all of this right here, then we cannot go here and type sum. this will not work. It will simply type the sum of A and B is sum. But what we need to do is we need to say here plus and then sum, which this sum right here refers to this integer right here, and this plus sign, it's gonna concatenate the string. Concatenation in this case means that it is gonna combine this string and this integer into a single string. So if we run our game now, we are gonna see the sum of A and B is 11. So sum A and B is 11. And if you're wondering why did I left here an empty space, so why didn't I put the end of the quote right here? Well, it's because I need to separate this sum from this string. Notice if I go and run our game now, we are gonna see that the sum of A and B is 11. And notice there is no space between is and 11. Let me just pop this right here. So there is no space between is and 11. And in order to give space, simply, well, separate and leave space right here. And why am I telling you this? Well, this is how you are usually gonna, well, print things to the console. You're gonna say script worked and print something with the script, so on and so forth, which we will see later on. So let us take a look at some other operations that we can do. I said that we can also perform A minus B or subtraction. So if I go here and hit the run button, we are going to see the sum of A and B is -1, but actually it should be the subtraction, or however it is called, of A and B is -1. Why? Well, because A is 5 and B is 6. And yes, programming languages can calculate negative numbers. So 6 or 5 minus 6 is -1. Moving forward, we have multiplication. So I can multiply it right here and go back here, run our app, and it's going to be 30. Why? Well, because 5 times 6 is 30. But one thing that we're going to notice now when we try to divide them, so if we divide A by B, we're going to get 0. So notice if I go here, we are going to get a 0. Yeah, so 0. Even if we go now here, if we go and let's say I change A to 8 and we divide 8 by 6, what we are going to get is 0 again. So going here, or actually 1. So excuse me for that one, we got 1, but that is not true. Why? Well, the point here is that if we divide 6 by, or 8 by 6, we know that's a decimal point number, and we know that these are integers. So integers cannot represent decimal point numbers. If we want a precise calculation of these numbers like this, then I'm gonna simply change them to floats. So this one also and this one also. But we need to add F here and F here. We don't need to add F on this one because we are dividing two floats. Previously, the result was 1. When we go back and run our app now, we are going to see the result is 1.333 and so on and so forth. Why? Well, because now we have more precise calculation, because 8 divided by 6, that's 1 point some number, apparently 1.33 and 333. And because integers can only hold whole numbers, well, that is the reason why we saw 1. Integers will round up that number to the closest whole number. So if it's 1.3, it's going to round it to 1. If it was 1.6, it will round it at 2. So the closest whole number. Of course, everything that applies in math using parentheses. So if we do something like this, for example, if I say here, open close parentheses, 2 plus 3, and then I multiplied that by, let's say, 4 minus, and I can again open here and close parentheses, and I can say 4 divided by 3, and I can close the parentheses again. This is gonna work. So it's gonna calculate, of course, it's gonna give advance or the priority, same as in math. So in this case, I think it's first going to calculate these two because they are in the first parenthesis. Then they are going to multiply, but they're going to wait. So when they need to calculate this, they're going to calculate 4 divided by 3 and then 4 minus that number. And then they're going to multiply this one by 4. I'm just curious which result is here because I have no idea. You see, I'm no math wizard, but I can program. And the sum is 15. Interesting enough, it's 15. I also want to mention that, for example here, we have a float, A and B. And let's say if we try to do this, float sum is equal to a plus b, not hide flags, but a plus b. This is all regular, this can work. If we go here, we don't have any problems, so on and so forth. But if we try this, if we say int sum is equal to a plus b, this is not gonna work. If we go back here, it says cannot implicitly convert type float to int. An explicit conversion exists. Are you missing a cast? What does that mean? Well, that means that we cannot put these two floats or calculate them and put them in an integer. We cannot, except if we cast them. What is casting? Casting is converting, for example, in this case, converting a float in an integer. And how can we do that? Well, in front of the variable, so in this case, a, we open close parentheses and we type int. And we can do the same thing for the b, simply copy the code and put it right here. And this is called casting. If we go back here, this error is gonna go away now. So yeah, the error is gone and we don't have any problems. And this is called casting. Bookmark this because it is important. And we simply put open close parentheses. In between these parentheses, you type the type of the variable to which you want to cast this variable right here. So this variable a is currently a float, which we see here. But since we want to put them in an integer, it does not allow us only if we use this cast. That cannot work. But vice versa, it works. So if this is int a and this is int b, and now we need to remove f here. So if this is int a and int b, we can say float sum is equal to a plus b, not start coroutine, but a plus b. And if I save the script and go back in Unity, we are not going to see any problems right here in the console. I can even clear it. We can even run the project and we will see the sum is 14. Because float can, or integers can be put in a float because they are whole numbers. Float will just convert them into a decimal point number. No biggie. But if you want to put them in an integer, then it will not work. And let me just test quickly here. If one of them is a float and another is an integer, this should work also for a float. Yeah, for a float that works, no problem. But for an integer, it also does not work. If we try it like this, int sum, even though the b variable right here is a float, and we are gonna, well, add that float to another integer, which is a right here, and put the sum of those two numbers in an integer, I don't think it will work. Yeah, it does not work. Both of these variables need to be integers because one of them is a decimal point number and another is not. Why it works vice versa, I'm not sure, but just memorize this. And it's the same for a double. So when I use float, and in any situation that float is involved, it will be the same thing for a double. So even if I go here and type double and remove f here because we don't need that for a double and go back here, it will simply change here, cannot convert type double to an integer. Previously, it stated cannot convert float to an integer. But this is just for you to know in case that you run into these problems. If you see this right here, it cannot convert them, then it probably means that you are trying. And even this is one of the debugging things that you should do. So immediately when you see here an error, double click on it right away and see where it is pointing. And from there on, you're going to start and debugging your projects. Later about debugging, we will see that in the course and I will show you how I fix my problems, so on and so forth. But this is how you would proceed to fix the problem. Double click on it, see where it's pointing, and it says cannot completely convert. And you're simply going to see, okay, int a, or the variable a is an integer. We are putting that in an integer, but b is a double. That does not work. But again, vice versa, it will work. If I simply change this int to a double and go back here, it will work. If it's a double here, you can use two integers here, no problem. But if it's an int here, you cannot use floats. All of them needs to be integers and you simply need to cast them. So in this case, you're going to cast b, open close parentheses before the variable, and then type the type of the variable you want to cast it to. And this is that scary concept regarding math in programming languages. Of course, if you want to be a programmer for 3D graphics, drivers, or something like that, then you would need to know 3D Math, which is a little bit more complicated than this, and I don't know it. Don't ask me, I don't know it. But if you want to make games like these that we are going to make in this course and other games that are out there, then this is the math you need and you're good to go. So this was the basics of operations with variables in programming languages. And Fahir here from AwesomeTunes.com, and I will see you guys in the next video. What is up, guys? Fahir here from AwesomeTunes.com. And in the previous video, we saw that in order for us to create an object from a class, we use this new keyword and we pass this that I said is called a constructor. Now, if we go back here, we did not declare that anywhere here in our class, but we have that by default because every single class that you create is inheriting from an object parent class. Later about that, but the point is, even though we did not type here public player like this, open close parentheses, we still can use that right here. And I have already given away, or given, tried to speak correctly using grammar, but not given. And I have already given you how you can create a constructor. So you type public and then you type the name of the class, which is player right here, open close parentheses, open close curly brackets. Now, what can we do inside of this constructor and what is the purpose of this constructor? Well, we see here that we have health at 100 and name is equal to wizard. And here, if I simply remove this knight name, or the name of the player is knight and health is 64, and I go here and simply type knight.playerinfo, if I run this in our console, no surprise that we are gonna see that player name is wizard and health is 100, which is what we set here to be. But inside of this constructor, when we create him, we can change these variables. So we can type here name, which is this variable right here, is equal to, and let's say knight. And health is equal to 43.1F. So we can do that. We can change the default values of these variables inside of the constructor and it will work. And we can even call these functions. We can go and right now we can simply call player info inside of this constructor. And I can go here, I can remove this or comment it out because we don't need it. And simply I can create a new function by calling the new player using its constructor, which is this one right here. So let's test that out. If I go here and clear the console and I hit here play, we're going to see player's name is knight and player's health is 43.1. How could that be? Because we set it here to be 100 and name is wizard. Well, we changed it inside of the constructor and we also called player info, which was executed when we called the constructor. So what is happening behind the scenes when we call new player or the constructor's name? It's happening that we are going, or the compiler is going inside of this constructor, looking if we have any code inside of it and executing that code as we just saw. Now, this can be a little bit troublesome. And with that, I mean, if we want to change the name, so by default, the name is wizard and health is 100, but we are creating here a player knight. Then we need to do this. Then we need to type knight.name is equal to knight. So knight like this. Actually, it's like this. And we also need to change the health, so on and so forth. Or we can do that in the constructor as we just did. So we can say here name is equal to knight and health is equal to whatever value we want. But what if we create a knight and we also want to create a wizard? What about that? Do we need to go back here and change the name back to wizard? But that will not work. Then again, our knight will also have the same value. There must be a better way. And yes, there is. Always, like in every TV show, there is a better way, Kevin. So what we are going to do is we can create constructors with arguments. Same as with functions. So below our no argument constructor, we can type public player. And now we can have arguments here. So we have health and we have name. So I can type here string name, comma, float health, and that's that. Same way as with a function, we separate arguments using a comma. So separate the arguments using a comma, and there is no limit to how many arguments you have, but usually when you create a constructor for a class, you are creating arguments that are the same name, or that who have the same name as the public or private, later about that, but as the variables that you declare inside of the class. So how can you now set these values to be equal to these values? Because these parameters only live inside of the constructor. So if we do something like this, so if I go back here in the tester, and if I create the player knight, and using here the name knight, and for the health I say comma 1, let's say 1. If I use knight.info, or player info, excuse me, well, we need to assign these values, these parameters, we need to assign them to these values. So what we need to type here is we need to type this.health is equal to, or excuse me, this.name, because it's the first argument, but you can also put the first argument, you can type it like this. So you can say this.health is equal to health, and this.name is equal to name. But usually I use the first argument first and the second argument second, third, so on and so forth. Now you are like, whoa, wait, what is going on? Yeah, I know, I use this. Yes, I use this. So what is this? What is this? Well, this keyword refers to this class right here. Now, I see people are getting confused with this keyword and why we are using it. We are using it in situations like this. So we have a string name, or a variable called name, which is a type of string, but also we have here a parameter called name. In order to differentiate these two, so instead of typing name is equal to name, we type this.name. Why? Well, because the keyword this is referring to the class where it is called. So if the keyword is called inside of the player class, it is referring to the player class. If this keyword is called here, this.knight or this.whatever, like this, it is referring to the tester class. So if you're in another class, for example, in pumpkin, and here you type this, so let me just remove this curly square bracket, that is, this.name, again, you are referring to the class pumpkin using the this keyword. So nothing confusing about it. So this refers to the class. And when we type this.name, this is actually referring to this variable right here, because this is referring to the player class. It's same as if we are saying player.name, which is this variable, is equal to name, which is this variable that we are passing here as a parameter. So like this, just so I can put here a, and this will remove the confusion. So this.name refers to this name variable here, and it is equal to a, which is this parameter. But since we are using name, because that's a conventional way to use it, we have here name, so we also use it here. In order to differentiate between the two, we simply type this.name referring to this variable is equal to name, which is this one right here. And that's that. So this is the whole point. And now, when we pass these arguments, they're actually gonna change these variables. So these right here, they are gonna change them. So when we go now and type here knight, and type 1 for the health, and use the player info to see all of that, notice what's gonna happen. Previously, we had wizard and player health as 100. When I run the game now, we have knight, and player's health is 1. Why? Well, because we have passed these parameters inside of the constructor, and then the constructor took over. So the constructor then simply assigned them here, as we explained a moment ago. So now when we type player info, it is actually gonna print these changed values. So it is gonna print these changed values, and this is the way to go. So the way that you are gonna use your classes, instead of going here and typing knight.name is equal to, and you give the name. What if you have 300 variables? I'm just kidding, you're not gonna initialize 300 variables like this, but just imagine if you have 300 variables and you're then typing knight.this variable is equal to this value, so on and so forth. By this way, you're simply gonna pass them in the constructor, and then the constructor will do the rest, which you're going to model again inside of your class right here. Now, this class or any other class can have multiple constructors. You can also have a constructor that only has one argument. So you can say player, and here maybe you only want to pass the name. So you can only pass the name, or you can have only passing the float, so on and so forth. That is your preference. When I say preference, that is more related to your logic, what you are creating and what you are doing. When we start creating our projects, you will see and everything will be more clear. Now, one thing to notice that if we have a constructor that has arguments, we cannot have, or we cannot go without a constructor that has no arguments. I think that we are going to get an error right here. Let me just take a look at, actually, no. Well, in some programming languages we do, but this is nice. This is actually nice. But if I try to do this, I think if I try to do this now, player K is equal to new player, I think now we are going to have a problem. So going back here, yeah, this is what I meant. So this is the problem. If you have a constructor that takes arguments, you need to also have this constructor that does not take any arguments. If you want to create a, default object that you have modeled with all of these default values, see, we are doing this here. Player K is equal to new player, but it is going here and it cannot find this no argument constructor. But vice versa, it works. Vice versa, it will work. If we don't have this constructor and don't have this constructor, we can still go. This one we cannot do now because we don't have it. But for this one, we can. Automatically, we have a no argument constructor, even though if we did not declare it. And that will work. And if I go here, we don't have any problems, as you can see here. And we did that in the previous video also. So by default, we can have a no argument constructor. But as soon as we add another constructor, then you will need to type this no argument constructor also if you want to create a default game object. And this is about constructors and how we can use constructors to initialize our variables right away instead of using these variables and then typing their values, which can be really painful. So catch you guys in the next video. Fahir here from AwesomeTudes.com, and see you then. What's up, everybody? Fahir here from AwesomeTudes.com, and let's talk about arrays. So tell me, what do you know about arrays? I'm just kidding, man. I'm gonna explain arrays. Do you thought that you're gonna explain? Yeah, enough about being silly. But what are actually arrays? Well, arrays are allowing us to store multiple types of the same data inside of that single variable. Let's say, for example, we want to create 10 integers. Instead of us typing like this, int a is equal to 3, int a1 is equal to 5, int a2 is equal to 4. Now, I am already getting bored of this typing. And this is messy. Let's say you create 10. Let's say you need 100. Then what are you going to do? You're going to type 100 times 8? No, you are not. Arrays to the rescue. So how can we declare arrays? Well, you declare first the type of the variable you want to store in that array. In our case, integers, and I'm always using integers as an example, but you can use strings, booleans, floats, doubles. It works the same way. So you first type the type of that variable, int, and then you open a square bracket and close a square bracket, and then you give it a name, let's say data, and it is equal to new int array like this. And it is giving us an error right away. You see this red line, and if we go here in our Unity editor, it says array creation must have array size or array initializer. What does that mean? Well, I mentioned a moment ago that if we want to create 10 integers, so let's say we want to create 10 integers and store them in this array. When we create that, we need to denote here that we want to create 10 arrays or 10 integers, excuse me. So this is an array of integers called data, which is equal to a new array of integers of 10 elements. Now, don't be confused about this new keyword. We will cover it in a couple of videos when we start talking about classes and objects. So don't worry about it. Just know that you use new to create a new array of integers. And notice it has 10 elements. So we type here number 10. It means it has 10 elements inside of that array. So what is the value of these elements inside of this array, you are asking me, and I'm answering to you. Well, if you don't initialize these integers, the default value is 0. Same as if we go here and we declare, let's say, int a like this. And we can do this. This is totally legit. It is legal to do. We have declared int a, and just like that, we did not type is equal to 3. And this is allowed for you to do. So you don't have to give it a value. But just know that the default value in this case here, if you don't give it a value, you don't type equal to some value, for example 3, then the default value is going to be 0. Same way for the array. We did not type the values of these 10 integers, so every single one of these 10 elements inside of this array has a value of 0. How can we change that? Well, we can change that by accessing every single one of those elements in that array and giving it a value. And how can we access those elements? Well, arrays are index-based. And in order to access an array, let's say we want to access the element that's at index 1, index 1, let's say. So if we go here, we need to type data, and then open close these curly brackets again. And now we need to pass that index here. So we want to access the first element. So the very first element in the array. We're going to type 0. And now it is equal to 44. And I know you're like, what is this guy doing? I mean, he typed 0, he's talking 1. Is he crazy? No, I'm not crazy, but arrays are 0 based. They have indexes that are 0 based. What does that mean? It means that the very first element inside of the array is not at index 1, but at index 0. So it goes from 0 up to array.length. And when I say array.length, I mean this. We can type data.length. You see this length, and it will give us the value or it will give us the exact number of elements inside of that array. And I'm going to print it out right now just to show you. So if I say print and I say here, the size of the array is, and I'm going to say plus data.length. Now data is this array right here. So the name of that array is data.length means give us the number of elements inside of yourself, so to say. If I go here in Unity, let me just clear the console and I run it, we are going to see the size of the array is 10, which is true because here we have declared that. So the size of the array is 10. And as I said, the first element begins at the index 0. So the first element begins at index 0 and the last element of the array is at the index data.length minus 1. And let's say that element is equal to, 32. So every time the last element is at data length minus 1. Why is it like this? Well, as I already said, the first element is at index 0. That means that the second element is at index 1. The third element is at index 2, so on and so forth, which means that the last element is not at index 10. Because we have 10 elements as we just saw, so you have data.length, and when you print that out, you will see that we will have 10 elements or 20 or 30, how many you put them here. But the last element is always at data.length or the length of that array minus 1. And this is how we initialize these arrays. So now the first element has a value of 44. The last element has a value of 32. Let's say the second element, so data1, has a value of 66. And now you are looking at me and asking me again, are you crazy, teacher? You said before that we don't want to type all of those arrays int a is equal to this value, int a1 is equal to that value, but it seems to me that we are doing the same thing here, and you're correct. You're 100% correct, but I'm not crazy. Instead of, I'm going to show you a very faster way how we can initialize these variables or these arrays. So instead of us typing data 0 is equal to some value, data 1 is equal to some value, we can use a for loop. Yes, that's correct. The for loop that we used in the previous video, we can use it to initialize our array. So we can use it like this: for int I, which is equal to 0, as long as I is less than, now we should have typed here 10, and I'm gonna say here I++, and we are gonna type here 10 because, yeah, we set here to have 10 elements in the array, but that's a no-no. Why? Well, we can use data.length. So we can go here, we can type data.length, so we don't need to change. Let's say we put here 10, but let's say we change our minds and we put here number 4. So we want 4 elements in the array. Then we need to go back and change that here, which is not good coding. But if we use data.length, or the length of that array, then we can, well, use it like this. So now, instead of us using every single index, so the index 0, index 2, index 3, and blah, blah, we can simply use the variable I. So we can go here, we can type data, and the element that's at the I index is equal to some value. Now, I'm not gonna put it here at 0, I am gonna initialize it with random values. How we can do that? We can use the random class. So you can bookmark this. This is called a random class, and we can use random.range between 2 numbers. So let's say 0 and 100. So notice here, notice the summary, returns a random float number between and min. So between minimum and maximum, exclusive and maximum inclusive. So this is inclusive and inclusive, read only. Well, in short, this is going to return a number between 0 and 100, and it is going to initialize all of our arrays here. Now, if I were to run our app, we're not going to see anything because we are not printing anything. So if we go here below and we print like this, and I'm going to say the element at index, and I'm going to say plus I, and again, we need to say here plus, and again, another string, has a value of, again, plus data and I. Why am I doing it like this? Well, I want to show you that the index, or the element which is at the I index, has a value, and we are going to fetch that element. If you are confused what is going on here, we know that we're going to loop. So looping means that I is currently 0, and it's going to go up to I is less than data.length, and we're going to increment I. So in the first iteration, I is going to be equal to 0, which means that we're going to access the element that's at the last index. In the second iteration, I is going to be equal to 1. Why? Well, because we are using this plus plus. I plus plus means I is equal to I plus 1. So adding 1 to I. So in the next iteration, I is equal to 1, which means then we are going to access the second element. Next iteration, I is equal to 2. So on and so forth. We are going to go up to the last element, which is going to be equal to I is equal to 9. Why? Well, data.length is 10. And we are going to go up to I is less than 10, which means 9 is going to be the last number that we are going to use, which is precisely the last element inside of that array. And this is the beauty of for loops. They are used to process arrays, because when I is equal to 10, this condition will not evaluate to be true anymore, and we will not execute everything here. So notice if I go back now in Unity and clear this up and I run my app, notice the element at index 0 has a value of 22. The element at index 1 has a value of 47, so on and so forth. I'm not going to read through all of these, but we see that we have initialized them with random values. Now, if I rerun this, the values are not going to be the same. So notice now the index 0 has a value of 44. Index 1 has 62, and they did not have those values before. Why is that? Well, every time when we rerun our app, we are going to reinitialize them with random values. We are not saving this data. We're not encrypting it. So that is the reason why. So this is how we process arrays, and this is how we use arrays. Which brings me to another loop, which is called a for each loop. So for each can also be used to process arrays, and it goes like this. So we type for each, open close parentheses, open close curly brackets. And here we're going to say for each integer, now we give it a name, num, in data. Data is our array. So this actually means for every or for each integer, which is called num, in our data array. Now here is an integer, but this is going to depend on the type of the array that you have here. Maybe you have an array of strings or of booleans or of floats or doubles. Then you will type that type here. Now, this is gonna iterate through the whole array, and this num right here variable, this num, is gonna represent every single element inside of this array. Now, how is that? Well, you know that we are going to iterate and then we are going to access the element that's at index 0, then 1, then 2, and so on and so forth up to the last element. So during that, each iteration, this num is going to represent every single that element. So in the first iteration, it is going to be the first element. In the second iteration, is going to be the second element in this array, of course, so on and so forth. Now, unfortunately, we cannot use it to initialize. We cannot say this, num is equal to random range 0, 100. If we try this and go in our console, we will see cannot assign to num because it is a for each iteration variable. So we cannot assign to it, but we can print it. So we can go here, we can use print. We can say the value of the element is plus num. We can do this, but let me just go here and check if the error is gone. Yes, it is, of course. And we can do this. We can print it, but before that, we need to initialize it. So I'm going to simply uncomment this out and comment this line of code. We don't need this to be printed because we're going to print it here just so that we see that we can use for each to iterate through an array. And if I go here in my Unity and run our app or game, we're going to see the value of the element is 88, 95, 50, and so on and so forth. So we can use also for each, and we notice we don't need to specify how many times it needs to loop as in our for loop, because this one will know automatically based on this data array. So it will loop as many times as many elements are in that array, and we don't need to worry about that. And this is practically it. And also, I mentioned now, you don't need to worry about that because it can happen that we access an index out of bounds exception. What does that mean now? Well, that means we have 10 elements in this array. We know that the last element is at index data length -1. In this case, it's index 9 because we have 10 elements. But what happens if we try to access the 10th element in that array? Let's find out. So when I say print here and I say the element at index 10 has a value of, and I'm going to say here plus data, open close curly brackets, and pass the index 10. Of course, this is not giving us any errors or problems. And even if we go here in our Unity, it's not going to tell us anything. But when I click here, the run button, bam. Index out of range exception. Array index is out of range. You're going to see this a lot during your development. I see it even now. So I'm not going to try to scare you or something, but this happens, and errors and bugs happen even to the best of the best of the best. So don't worry about it. So you're good to go. But I just want you to know what this is about. When you see index array out of range or array index out of range, that means you are trying to access an index in the array that does not exist. If you double click on it, it's going to show you automatically on the line of code where you have a problem. But the point is, index or array index out of range means that you are trying to access some index that actually does not exist. What I mean by that is that this array has 10 elements. The last element is at index 9. We are trying to access the element that's at index 10, which is not possible because we only have 9 indexes from 0 up to 9. That is, we have 10 elements in total, but from 0 up to 9 indexes. After 9, we don't have any more indexes. If we say here that our array has a value of 20 and we try to access 25, that's not gonna happen because we have 20 indexes from 0 up to 19, or 20 elements, but from 0 up to 19 indexes. So index number 25 does not even exist, and you are going to see this type of error: index or array index out of range. And you will see that a lot, as I already mentioned. And I'm telling you now, bookmark this. This is really important. So bookmark it here on Udemy. You have this somewhere here in the middle. You have bookmark it. What is happening here? So bookmark it. And that way you will know where to search it when you have a problem. But this means, and use some, I don't know, pen and write that on your head. When you see array index out of range, it means you are trying to access an index that does not exist. And that's that. And I repeat it so many times because it's really important. Maybe some of you will be bothered by it, but it's really important. That's why I have emphasized it. Anyways, this was about arrays. So in short, you use this open square bracket, close square bracket, name it, new int array. This is how you declare it. Of course, you can declare it same as a variable. So you can say int array, and I can say elements. So elements like this, and I can simply type here without declaring it, without typing is equal to new int, so on and so forth. But this is an empty array, does not even exist. Only when we add or equal to new int array, then we can make this array have elements. So Fahir here from awesomedudes.com. End of the video, and I will catch you guys in the next one. Welcome back, Fahir here from awesomedudes.com, and in this video I want to talk about a concept that is called a function. Now, I talked about them here, and we even created one. This is one here. And what is a function actually? Well, a function is a way for us to have a block of code that we want to reuse over and over in our project. Then we group that code in a function, which will make us write cleaner code, and it's much easier to maintain and whatnot. Now, I like to group functions in 4 categories. And let's go one by one and break them down. Of course, this grouping is my grouping. I don't think programmers in the world do it like this, but I do it in a way to explain it. So this is much easier for me to explain what it is. So how do we declare a function? Now, there is a function that returns a value and that it does not return a value. So don't worry about it right now. It will be clear in a second. First, I'm going to declare a function that does not return a value. And it begins with void. So yeah, void, this is right here and here and here. So it's already familiar. We saw it once. Void means the function that we are going to create now does not return any values. And now we give it a name of the function. So what the name is going to be, let's say calculate 2 numbers. And this is the name of the function, which again depends on us, same way as with variables. And now we open close parentheses and open close curly brackets. The code that we put between these curly brackets, so this one, and I'm going to write a comment, the code that we put here is going to be executed every time we call this function. So this is a function that's going to calculate 2 numbers and return or print their value. So let's do just that. So we can say here print, and I can say the sum of A and B is, and I can say here plus 3 plus 5. This is going to calculate these 2 numbers, and we can even leave them here in parentheses or put them in parentheses just to make this more clear and not confusing. So again, we are concatenating the result, and here I'm putting in parentheses 3 plus 5. This is equivalent even if we write, for example, int sum is equal to 3 plus 5, and then here, instead of typing 3 plus 5, we simply type sum. So it is going to return 8, and this right here is also going to return 8. But instead of creating a new variable, we're simply doing it here directly. And how do we call a function? Simply call the name of the function. So this function is called calculate 2 numbers. Simply type calculate, and here it is because we have declared it in our project. We are getting autocomplete for Mono Develop. Simply tap on it and open close parentheses and end the statement with a semicolon. And this is it. So you simply type the name of that function, which is right here that we have declared, open close parentheses, same way as here, and end the statement with a semicolon. So if I go in my project now, and if I first clear the console and run the game, we're going to see the sum of A and B is 8. So the sum of A and B is 8. It's the same even if we use this to simply call it right here like this, it will also work. So like this here. But the point here is to explain what are functions. So this is the first type of function, or how I like to categorize them. This function does not return a value, which is denoted with void, and it does not take any parameters, which is denoted by these empty parentheses. Let's make it more adapting to our needs. Now, this is a function that calculates two numbers, but every time we want to calculate two different numbers, we need to go here and change, for example, to 6 and let's say to 4 in order to calculate these numbers. But when our program is running, that is not possible for us to do. We can only do that in code. But how can we make this function a little bit more adapting? For example, I don't want to go and change these numbers here. Maybe I want to change the numbers here. Is that possible? Yes, it is. We add parameters to the function. Let's say now I'm going to comment this function out, and here I'm going to remove it because it is giving us a red alert. We don't have that function. Again, comments are not compiled by the compiler. You can write whatever you want and it will not be compiled. So now I'm going to say void again because it is not returning any values. And I'm going to say calculate two. So calculate two numbers. And now I want to have two numbers as parameters here. How do we add parameters, and what are parameters or arguments? They are either called parameters or arguments. And what are they? Well, they are regular variables, integers, floats, doubles, booleans, objects, anything else. Don't worry about objects. We will cover them later on. So let's say we want to calculate two integers, and I'm going to say here int a, comma, int b. What does this mean now? Well, it means that our calculate two numbers function now has two parameters, a and b. Both are type of integer. If we want to only have one, then we will simply remove here int b and remove the comma. If you want to add more parameters, you separate them by comma. So you first type the type of the variable that you want to be as a parameter, then you give it a name. So here I'm going to say comma, and I'm going to say again int b. And instead of typing now the sum of a and b is 6 plus 4, and I'm going to copy this right here just so that I don't retype it. Instead of 6 plus 4, I'm simply going to say a plus b, and this is going to work. So how do we call this function now? Well, we call it the same way. So we call it calculate two numbers, open close parentheses. But now what we need to do, since we have these parameters here, we need to pass them right here. And since they are integers, we need to pass whole numbers. So let's say 4, and now we need int b, and it's separated here by comma, so we also separate it here with comma, so 4 and 8. And now this 4 is going to take the place of int a, and 8 is going to take the place of int b. So this is how parameters work. And we can reuse them inside of that function as we just did right here. So we have int a, int b, and we are reusing them here to calculate their sum. If I go now, we are going to see when I run the app 14, because 6 plus 4, it was 4, I mistaken. I don't know math, you see, I don't know math. But I'm mistaken, this was 6 and 8. So 4 and 8, and we see the result is 12. Why? Well, because 4 plus 8 is 12. And I'm using, all the time I'm using sum and a plus b. We can also do this with a minus b. We can do it with a divided by b or multiplied by b. It will be the same. So it will be the same, no difference whatsoever. So this was another type of function that returns no value, denoted by void, but takes two parameters. And by the way, you're not limited to only having integers as parameters, and you're not only limited to have two parameters. If you want to have more, you can say here comma int c, comma int d, up to unlimited number of parameters. And as I said, you're not only limited to integers, you can say bool g, string a, and all of these parameters, you can reuse them. And I cannot say a because we already declared a. You cannot have two variables bearing the same name. That is not possible. So now we can reuse the boolean inside of the function itself and reuse the string inside of the function itself. So again, you're not limited to only integers as types of these parameters, and you're not only limited to 1 or 2 parameters. There is no limit to those numbers. Another type of function is a function that returns a value. So far, I was talking about this function does not return a value. Now this function returns a value. And what does that mean? Well, let's say, for example, we have a function that is going to return an integer, but before that, it's going to calculate 2 integers and return a sum. Since we are working with integers, and again, I'm using integers as an example, you can use booleans, floats, doubles, strings, it works the same. So we want to return an integer. Instead of typing void, we type integer int because that's the type of the variable we want to return. And again, I'm going to say calculate 2 numbers, and here in a function that returns a value, we need a return statement, and it goes like this. Simply type return and now return the value. So we can say 5 plus 6, and it is gonna return the sum of 5 plus 6. We can go here and we can print that. So I'm gonna take this print here and I'm gonna say the sum of a and b is, and remove this from here, and I can simply call the function inside of it. So I can call the function inside of it, and if you're confused why, well, the reason for it is returning an integer number. This is a function, but when it calculates these numbers, it is going to return an integer. So I can do something like this. I can say here int sum is equal to calculate 2 numbers, and it's going to work. Instead of using that function right here, I'm simply going to type sum, and it is going to work. If this function is going to return a string, you can do the same thing. So you can type here string, name it, and take the function which is going to return that value. So it's simply returning that value, and you can practically catch it inside of this variable right here. So declare a variable and call the function. It will return that value and put it inside of this variable. So now if I go back here and let me just clear the console first, go in the console, clear it up, run the project, we're going to see the sum is 11. Even if I remove sum right here and pass again the function itself and delete this right here, it will be the same. No difference whatsoever. If I run it, we are going to again see the sum of a and b is 11. Why? Well, it is returning an integer. And again, I'm repeating the same way it will work for a float, for a boolean, for a double, and a string. So we are not only limited to integers, but I'm using them as an example. This was the third type of function that I was talking about. And we have the fourth type of function, and it is gonna be int. This function returns a value, but it also takes parameters. So I'm gonna say calculate 2 numbers, and now this one takes 2 parameters, or 3 or 4, or however you want, or how many you want. So let's say int a comma int b, and now instead of typing return 5 plus 6, I'm going to simply say return a plus b. So now we don't need to hard code these values, and every time it's going to be 5 plus 6. Now we can simply pass parameters. So I can go here and I can type calculate 2 numbers, and I'm going to say, I don't know, 77 and 11. And now 77 is going to take the role of int a, and 11 is going to take the role of int b. And here we are adding them up and returning them back. And it's the same concept right here. That's why I can type the function name here, and it will execute along with the print statement. It will concatenate as an integer with this string. Or we can do the same thing. We can say int sum is equal to calculate, and I'm just gonna copy it here so that I don't retype it. So calculate like this, and it is gonna calculate these 2 numbers, put them in the sum variable, and we can call sum right here the same outcome. So the outcome is the same. If I go here and run our app, we are gonna see 88 being printed here in the console. So this is the whole concept of functions, and we have used them right here. So now we have here created, if you remember, move pumpkin. This is the name of the function, and we see it's void. It does not return anything, and it takes no parameters, but we need this code to use it in our update function. Now you're wondering, why didn't I just put this code in the update? Yes, I could have. Could have worked, or it will work even if you put it, but I don't like to put all of my code without grouping it into functions in the update or fixed update or here in the start or in the awake, because in my eyes, it does not look pretty. Just imagine if, for example, in the fixed update, you have this. So you have this code and maybe another line of code, maybe another line of code. Look at this mess. It does not look pretty, and we can confuse ourselves and even confuse somebody else who takes a look or watches our project. Instead of, we can simply regroup all of this code in a single function and then call that single function. Look at how much prettier this code is. This is much prettier and easier for the eyes. And now if you have any problems, you're going to go inside of this function and then fix that problem. So this was the function that we have created. And also I want to talk about one thing, that is the names of these functions. Now we see here that I named all of these functions calculate two numbers. For example, if I uncomment this one, and let me just go here in Unity Editor, we are not going to see any errors. But if I go and type this, void calculate two numbers, and put it like this, if I go back in Unity Editor, we are going to see an error. Notice here, it has calculate two numbers is already defined. Rename it or use a different parameter types. What does this mean? It means we cannot have two functions with the same name. And you're like, what? But this is calculate two numbers and this is calculate two numbers. What are you talking about? Well, you see the concept of that function. This is void, it does not return anything. And this is void, it does not return anything. This does not take any parameters, and this one does not take any parameters. So it's practically one and the same function, these two. But the difference between these, so notice this one, this is also called calculate two numbers. But this one returns an integer, and it also takes two integers as parameters. It has the same name, but it's completely different function. So it's a different function, it has two parameters, and it has an integer. Now don't be confused when I say different. This one calculates two numbers, this one also calculates two numbers, but C# or the compiler is treating them as two separate functions, even though they have two same names. Why? Because of the signature. And I mean, with the signature, this one has two parameters, this one does not have any parameters. Even if I go here and I type it like this, and I add only here int a, I'm not going to get this error right here because this is a different function. Notice the error has gone away. It's treating it as a separate function because this one takes a parameter, this one does not take a parameter. So this is a good thing to know. Even if I uncomment these two and all four of them have same names, I don't think that we are going to get any error here. Actually, yeah. Let me just go here, calculate. Yeah. We are getting the same error. So apparently, even if this one is returning a value and this one is not returning a value, they are calculated or they are counted as the same function. So we would need to comment this out. But let me just see for this one will not be counted, I think. Actually, it is. Yeah, because we have practically here, we have the same, but this one returns an integer and this one does not. So in this case, it will not work, but in this case, it will. So this one returns an integer and this one does not return anything. We can have them as same names. So calculate two numbers, calculate two numbers. I just wanted to take this out of the way because I did not see anyone explaining this. Even I did not explain it before, but well, I saw an importance to this in order to explain it because maybe you will need to put same names but have different implementations of those functions for some reason, and it is good to know. Anyways, this was about functions. What are functions? How we can use them? How we can declare them? Fahir here from awesometudes.com, and I will see you guys in the next video. Well, look who is back. Thirsty for knowledge, you want more. I like that. I'm just kidding. Fahir here from awesometudes.com, and I want to talk about a concept that is gonna allow us to control the workflow of our games and programs if we create programs or apps. And that concept is called conditional statements. We already created one in our pumpkin class and I use it as an example. This right here, this if statement, that's a conditional statement. It's if. We are asking if this happened, then do this. So how does it go? Well, we type if, and then we type open close parentheses, open close curly brackets. The condition that we put inside of these parentheses needs to evaluate to be true if we want to execute the code that's right here between these curly brackets. So if we want to execute the code that's right here, we do need this statement to be true. So we can simply type here true, which is a Boolean variable. And I told you that when we talked about Booleans, this right here, we are comparing our position y. If it's less than -10, that will either be true or it will be false. And I can go here and I can type print, the statement is true. If I go here in Unity and run our game, we're going to see the statement is true being printed in our console. I'm going to clear it and go back. And if I set it to false, this will not be printed. If I go here and rerun our app or game, nothing is being printed. It says unreachable code. And in fact, it is true. This is unreachable code. False will always be false and we will never execute the code that's right here. Let's take a different approach. We have something called comparison operators that we can use, and we saw that this one right here, this less than sign, is called a comparison operator. So we can have int a, which is 6, and int b, not EBT, it's int b, which is 3, for example. And here, instead of using false right away, I can simply say or ask if a is greater than b. So if a is greater than b, we can type here a is greater than not dab, man, I'm not dabbing here, than b. So if this is true, and in this case it will be because 6 is greater than 3, we can go here and we can print this in the console. So a is greater or greater than b. So this is it. This is called a conditional statement. And of course, we have more of these comparison operators. We have less than, but now it will be false because, well, a or 6 is not less than 3. In this case, if we want to have more conditions, let's say, for example, if a is actually not lower than b, but we want to execute something if that is, well, if that happens, what we can do, instead of us using this right here, going here and typing, okay, if a is not less than b, then a is maybe greater than b, and then we can execute some code here. No, this is the wrong way to approach it. We have something called an else statement, and this is called if-else statement. So here, if a is not less than b, then we will not execute this code. If this right here is not true, then we will not execute the code. But we want to execute some other code, then we can use else, which means the same way as you read it. Just read this and it will be clear to you. If a is less than b, execute the code that is here. If a is not less than b, else execute the code that is here. So what I'm going to do here, I'm simply going to copy and paste it. A is not lower than b. So if a is not lower than b, then we are going to go into the else statement and print this in the console. And I can go here, I can run the game, and we're going to see a is not lower than b. Why? Well, because 6, which is a, is not lower than 3, which is b. We also have some other other comparison operators. And we can do it like this. Let's say we test if a is less than b. But we also want to test, okay, if a is then equal to b, and if a is greater than b, then how we can test that? Well, we can type else if, instead of typing only else, so not only typing else, we can type else if and give it another condition to check it out. And again, we need parentheses, open close parentheses, and here we need to put that other condition. So we want to test if a is less than b. If that's not true, then test if a is equal to b. And we test that by using double equal sign. Don't compare or don't confuse double equals with a single equal sign. What is the difference between them? Well, a single equal sign assigns this value to this variable. So a is equal to 6, meaning the value of a is 6. But if a double equals b, that means test if a, or the value that's inside of a, if that value is equal to b. So if this is also not true, we want to test if a is greater than b, then we're also going to say else if a is greater than b, then what we can do here, execute the code, of course. A is lower than b, we're going to print that here. A is equal to b, not than, but to. So equal to b, and here we can say a is not, or actually a is greater. Here we need to say greater than b, or not lower. If it's not lower, then it's greater, but it can be equal to. So what do you think, which one of these is going to execute? Well, it's going to execute this one, and we can test it right now. I'm going to simply clear everything here in the console, run the app, and we're going to say a is greater than b, and if I double tap it, it's going to point me to this line of code. Why? Well, because first, we try to test if a is less than b, which is not true because 6 is not less than 3. Then we tested, okay, else if a is equal to b, meaning if this value here is equal to this value here, which is also not true, 6 is not equal to 3. Well, then test else if a is greater than b. We can also do something like this. We can test if a value is less than or equal to or greater than or equal to. So I can go here and I can type if a is lower than b, but I want to test it if a is lower or equal to b. I can also add here the equal sign, and this right here means if it's less than or equal to. And I can also add here the equal sign, and this means if it's greater than or equal to. So it will be true if we put here 6, then we are going to say a is lower than b, or it is equal to b. And we can do the same thing here. We can just copy this right here and put it right here because it will be the same result. A is either greater than b or it is equal to. So this right here will be true if a is 6 or greater than 6. And in this case, it will be true if a is 6 or lower than 6. And what do you think, which of these is going to execute? Let's check it out. And I will explain you how this works. So when I run the game, we're going to see a is lower than b or equal to b. This one is not executed. Why? Well, these conditional statements are tested like this. So we first test this one, then this one, then this one. But actually, if this one is true, the first one that is tested, if it's true, all others are skipped. Even if the second one is tested and it's true, all others below it will be skipped. No matter how many if-else statements you have below, if one of them is true, all others that are below that one that are true will be skipped. So in this case, this one is true, but also this one could be true because a is either greater or equal to b. This will only be false if a is lower than b, and this will only be false if a is greater than b. So if I put here 7, we are going to see that a is greater than b or equal to b. And if I run our app right now, we are going to see a is greater than b or it's equal to b. Why? Because a is 7, it's greater, and this one is not executed because, well, it's not lower or equal to. And this is my point. So if this one is true and it's executed, all others are ignored. Now we can also have statements like this. So let's say I'm only testing if a is, let's say, lower than b, or if a is greater than b. So I'm only testing these two, but they can be equal. I'm not testing that. They can be equal to. And I can say here a is lower than b. And I'm going to remove this one. And here I'm going to say a is greater than b. So only one of these two can be tested. And if I go here and try to run this, nothing will be printed here in the consoles because a is neither greater than or it is lower than. It is actually equal to. Now, instead of us typing here else if a is equal to b, because there will be situations where you only have two conditionals and you have the third one as a default one. What does that mean? That means if this one is not true and this one is not true, then execute this one. So execute it 100%. And here I can simply go and type a is not greater than b, nor is it lower than b. Like this. And if I go here in Unity and I hit the play button, we are going to see A is not greater than B, nor is it lower than B. This one acts as an default state, meaning if nothing above is true and nothing above executes, then execute whatever it is here. Because sometimes you will have these types of statements or these types of situations in your game where you want something to be executed no matter what. So if the conditionals above else are not true and don't execute, then execute whatever it is here. We also have one more conditional statement, which is called switching case, which I'm going to show you right now. It is similar to if statements, and it works like this. We type switch, open close parentheses, open close curly brackets. And we need to give it a conditional here in the switch. Let's say we go here and we type int a is equal to 6. And we put a because we want to test a inside of the switch statement. This is also called switching case. Why switching case? Because now for this tester here, or the variable that we want to test, we write cases. So let's say case 1, then colon, and then we type here break. And this can go over and over again. So let me just put it right here. And in case if you're wondering how am I doing this, moving it like this and this, I'm simply holding shift and then tab to move it backwards. So to tab it backwards and only selecting them and pressing tab to move them forward. And I'm gonna write or command V and command V one more time. And let me just move them here. And let's say, I don't know, 5 and 6. What does this mean right here? So this means that we have created a variable A and we want to test it. So switch and we are testing A. These cases are actually the values of this variable. So we're testing case 1, but actually here we are asking if this variable A is equal to 1, if this variable A is equal to 5, and if it's equal to 6. Now, of course, 6 is gonna be printed. So here I'm gonna say print, and I am gonna write A is equal to 6. I don't even care about these because, well, A is 6 and we know that's gonna work. But if I go here and hit run, we're gonna see A is equal to 6. So we are testing the condition, or we are testing, apparently, MonoDevelop likes this to be back, and I'm gonna allow it. So we are testing the value of the variable that's here inside of these parentheses. So in this case, this is an integer, but this can easily be a float. It can be a string, but you will type here the values of the variable that you are testing. So for example, if this is a string, so if we go here, string name is equal to Carl, like this, and you type here name, then instead of 1, you're gonna type, let's say we're testing if the name is Kenny, then we're gonna test here again as a string if the name is Carl and if the name is John, so on and so forth. This is just showing you that we are not only depending on integers. I'm just using that as an example. So here again, we are testing this int a variable, and we're testing its values. Notice this break right here. This break means break out of the cases, or break out of the switch and case statement. As soon as we hit one of these cases that are true and execute the code, of course, what we put between this case and this break, so this one right here, this is our code. Whatever we put here, if this case is true, what's in here will be executed. And when we execute all of the code and hit the break statement, automatically we're going to break out of the switching case, even if that case is number 1. So if I go here and move case 6 right here at the top, and even if I have these right here, so if I have this right here is equal to 1, and here it's going to be equal to 5, not 65, but 5. Even if we have these here, again, what is going to be printed in the console, A is equal to 6. Notice here, A is equal to 6. We don't even bother, same as with the if statement. If the first or the second or the third if statement is true, all below it, all other statements that are below it will not be even tested. And in this case also, even if I type here, but we cannot actually do that here. We cannot type case 6 2 times. We can only type it once. If we go here, we will see a problem. Because we can only test one case once. We cannot test the same case multiple times. But even if we could, then this first one will only execute, and then we will use the break or hit the break statement and break out of, well, switching case. Now what happens if we say here case 3, and here I'm going to say is equal to 3. And I try to run this, and we are going to see nothing printed here in the console. This right here was printed before, which you just saw, but nothing is printing in the console. Can we make something like this else right here? Actually, we can, and that is the default case. So we can simply type default, open these parentheses, or excuse me, not parentheses, but colons, and then type below it break, like this. And I'm simply going to use this one right here, and I'm going to say no case is executed. Instead, default is executed. And this is it. If I go back, run it, we are going to see that no case is executed. Instead, default is executed. So if neither of these cases are true, nothing here executes, but we do want to execute some code, then you will put a default case. Now, some students were asking me in my other courses, what is the difference between if and switch? So if, else, and switch statement, is one better than the other in terms of optimization? In terms of optimization, I'm not sure. But if my rough guess is, then if statement is better in terms of optimization, but I don't think that that's the case. But in most cases, you're going to use if, else statements. And sometimes you will need switch because it will make your code cleaner and better, but these are the conditionals that you can use. So if, else, and switch and case. I am going to comment this out and go back to if statement. What I want to talk here is that we can have nested if, else statements. What does that mean? That means that, let's say we test this condition right here. So if A is lower than B, and even if I put A is 3, which is, well, lower than B, but I want to test it again here. So let's say I want to test, okay, A is lower than B, but is A lower than 2? So I can say, okay, if A is lower than 2, and then if that is true, we are going to proceed inside of this if statement, execute the code or execute more if else statements. So we can nest them. This is called a nested if statement, or if we add else, it will be nested if else statement. So we can put them inside of other if else statements. Now, since this is a game, and especially if we are doing something here in the update function, because that's called every one time per one frame. If we have 60 frames in a second, that's 60 times in a second. Don't nest these too much. So during game development, try to don't nest like 5 or more. I think that this is my rough guess, but you can test that out and see the performance, but don't nest too much. Don't nest too much in game development, especially in the update function. Don't ever do that, or otherwise you will pay the consequences. You will pay the price. Enough about the scary voice, and I hope that I did not scare you so that you lose your focus, because there is one more thing that I want to cover, and that is, I'm quickly gonna comment this out. We can test two conditions at once. How do I mean that? Well, let's say, for example, here, A is 3 and B is 6. Let's say we have int C, which is equal to 2, for example. I can say here if A is lower than B, and that's one condition. And I also want to test if A is greater than C. How can I do that? I can do that in this same condition right here, and I can write these double and sign, and I can say if A is greater than C. So what does this mean right here? This means that if A is less than B, so this means and A is greater than C. And this will only be true if and if A is lower than B. So if this right here is true, and if this right here is true. In this case, it will be true because A is lower than 6, or lower than B, which is 6, and A is greater than 2, which is C. So I'm going to go here, use print, and I am going to say here in quotes, and I can write, this is true, just so that we test it out and see if it actually works. And if I go here in Unity and run it, we are going to see that this is true is printed here in the console. If by any chance C is equal to 3, this right here will not be true. And I will prove it to you. I'm going to clear everything in the console, and I'm going to run our app and see nothing is printed in the console. Why? Well, I said when we use this double and sign, that means that what's on the left side of it needs to be true. So what's on the left from it needs to be true. And what's on the right from it needs to be true. So A needs to be lower than B and A needs to be greater than C in order for this complete statement right here to be true. And this is called, I forgot the name of this operator. If I remember, I will tell you in the comments. But anyways, this is double and signed. And you read it like this. If A is less than B and if A is greater than C, then this is true. We can also use the double pipe sign. So double pipes, these right here, these double pipes, they're called pipes, well, as far as I know. And this means if A is less than B or if A is greater than C. And in this case, if this is true, then it will be executed right here. If this is also true, it will be executed right here. Even if this is false and this is true and vice versa, again, this will be executed right here. When we use the double pipe sign or the pipe sign, only one of these statements, so what's on the left from it and what's on the right from it, needs to be true in order for this to work. Now we know that A is not greater than C because C is equal to 3, but we do know that A is lower than B, which is true. So if I go here and rerun our app, we're gonna see this is true being printed in the console. And indeed, we see it. Why? Well, this does not require both of these to be true. This only requires one of these to be true. So we are testing essentially if A is lower than B or if A is greater than C. And if only one of them is true, then we are good to go. But if A is equal to, let's say, how do I need to do this? I can put B to be 3. And only if this is false and this is false, nothing will be printed in the console. And in this case, I'm gonna clear it and run it, and we see that nothing is printed. Why? Well, because B is equal to 3, and 3 is not lower than 3, nor is 3 greater than 3. And that's the reason we did not get any trues here, and that's why this did not get executed. So we have the double and sign, which requires both of these. So both of these sides to be true in order for this to work or to be executed for the code here. And we have the pipe sign or double pipes. And this requires only one of these to be true in order for us to execute this statement right here. And if you're wondering for what we can use if statements in our game, well, just a small example from on the top of my head. In our game, we're gonna have players' lives. So we're gonna test when the player dies. If players' lives are greater than 0, we can continue the game. Otherwise, game over, restart again, pay us again to play our game. Not just kidding. But yeah, this is just one example. We will see that later on when we start building our games. In short, if this can be called in short, this was about conditional statements which allow us to control the workflow of our app. Fahir here from awesomedudes.com, and I will catch you guys in the next video. What it is, people, Fahir here from awesomedudes.com, and what we're gonna cover in this video is a concept called loops. And we use loops to have a repetition of a single task. So if we want one task to repeat multiple times, we use loops. Now, to make things clear, let us just cover it. And the first and most famous loop in the world is called a for loop. And the context or the body or the concept of that loop goes like this. So we type for, and then you need to give it a condition inside of these parentheses. So usually it goes like this. Int I is equal to 0, then semicolon. As long as I is less than, let's say, 10, increment I by plus plus. So, whoa, what is going on here? Well, for, and now we have a condition. So for int, or integer variable named I, which is equal to 0, as long as I is less than 10, increment I and do the following. First, let me explain this right here because this is the first time we see it. I++ means this, means I is equal to I plus 1. A shorthand for this, or excuse me, a shortcut for typing this is simply typing plus plus. This means we are adding 1 to the value of I. So no matter what value is, we are adding 1. So this right here, this is the same thing, but a shortcut for it is typing plus plus. We can also type plus plus I like this, and this means increment the value of I and then use it. This right here means use the current value of I and then increment to it 1. But here we are first adding 1 to I and then we are using it. So that's the difference. And what does this body mean? What does this loop mean? Again, we're going to read it and I'm going to explain everything. So when you go from the left side and start reading it, this means for integer I, which is currently equal to 0. So this is the first condition, or this is the beginning of the loop. As long as I is less than 10, now this is the condition. So as long as the value of I, which is currently equal to 0, as long as that value is less than 10, do what is here in the loop and also increment I by 1. So let's print I and see its value. So I'm going to say print and I'm going to see the value of I. And here we need to type is, of course. So is, and I'm going to say plus I. Like this. What do you think the value of I is going to be? It's going to be, and let me just go here and show it to you. So when I run the console, it's going from 0, 1, 2, 3, 4, 5, 6 up to 9. But if you see here in the console, it is being printed 10 times. And if you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is printed 10 times. But why is the value, the last value is 9? Didn't we type here as long as I is less than 10? Well, yes, we typed it, but when I is equal to 10, this condition here will not be true because 10 is not lower than 10. And that's the point here. But it is printed from 0, including 0 up to 9. So in total, 10 times. And now everything that we want to be executed, we print, or yeah, I'm saying print because I'm reading it here, but we put that between these curly brackets. So all the code that we want to execute, we put it here. If we have a function or if we want to do something else, we would put that code and execute it how many times we want. In this case, we are executing that 10 times. Now, this is not the only loop that we have, and I'm going to comment this out. We also have a loop called a while loop, and it goes like this. So while, open close parentheses, open close curly brackets. For the while loop, the condition like this one in the for loop is a little bit different. So the condition that we put here needs to evaluate to be true if we want to execute the while loop. So if we want to rewrite this, what we wrote for the for loop, if we want to rewrite it here in the while loop, then what we need to do is we need to type it like this. So we need to say int I is equal to 0. And here we need to give the condition. So as long or while I is less than 10. So we are essentially asking here or telling us, just read the code. It's like reading a story. So while I is less than 10, do the following. So here we can print. So here we can use and print the value of I. And let me just copy this and paste it right here. So the value of I, and we can print it. But one really, really, really important thing, and you should bookmark it, is when you are using a while loop, you need to make sure that this condition here eventually evaluates to be false. How you can do that? Well, below, here we are going to write, because we are checking as long as I is less than 10. Currently, I is equal to 0. If we leave it like that, this will be an infinite loop and our program will crash. So we need to increment I. So here I'm going to say I++ simply like this. This is going to add 1 to I, which I talked about before. So it's simply going to take the current value of I and it's going to be equal to I+1. So it's simply taking the current value of I, adding 1 to it, and assigning that value back to I variable. Why? Well, let's say we loop 1 times, 2 times, 3 times, 1,000 times, but we are not incrementing I. And the condition here, as long as I is less than 10. I is currently 0, and 0 is forever less than 10. So this loop will run forever. But if we add this I here, plus plus, that means we are incrementing I, and this is gonna run 10 times. Again, we are gonna see the same printing as we did here. So the value of I is 0 up to 9. Notice here, I'm gonna clear the console first, run it now. And again, we see the same outcome. So the value of I is from 0, 1, 2, 3, 4, 5, 6, 7, and 8 and 9, of course. But as I said, this is a different loop, and we need to add this condition. If we don't add this condition, then this loop will never finish and our program will crash. The computer will explode. No, I'm just kidding. Don't worry, the computer will not explode, but the program will crash. And you can test that if you want. I'm not gonna do that because I don't want to reopen the program while I am recording. And we have one more loop, which is called a do while loop. And how does that go? So it goes like this. We type do, open close parentheses, or curly brackets, excuse me, and here we add while, open close parentheses, and we end the statement like this. But here we now need to add this condition. So I'm gonna take int I, which is equal to 0, and here we need to say as long as I is less than 10, for example. Now you are wondering what is the difference between this and this. You also see while here, but here you see do and while. And by the way, we need to put the code here. So code goes here that we want to execute. It does not go after this while like this. This is a no-no and it does not work. So yeah, it goes between the curly brackets of the do. Now the difference between the while and the do while loop is following. The while loop first checks this condition. So it first checks the condition if the condition here is true. So if I is less than 10, then execute the code. If I is not less than 10, do not execute this code. But a do while loop will first execute the code that's here, and then it will check for the condition. So are you with me? The do while loop first will execute the code here, and then it will check the condition of that code. So if we do something like this, if I say print, and I'm gonna copy this again. So here I'm gonna copy it, put it here, save it, and go back, clear the console. We are gonna see the same output, but I'm gonna show you something in a second. Oh, actually, I forgot to put, oh no, please don't crash on me, please. I forgot to put here I++. This is what I was talking about. You see, Unity now crashed on me. Not responding. You see, this is what happens when you have an infinite loop, yeah? And don't ever do that. So again, make sure that you finish or that you add a condition that will evaluate to be false eventually. So going back, I've added here I++, and you were watching this video and were like, look at him, man, he did not add a condition, his program's gonna crash. But yeah, I don't want to talk about it. When I run it now, we again see the same output from 0, 1, 2, 3, 4 up to 9. But what I want to show you is the following. As I said, the do loop or do while loop will first execute the code and then it will check for the condition. Let's say I put here I to be equal to 10. Now, 10 is not less than 10, and I can even comment this out now. So I don't need this because, well, why should I? Because I is 10 and the condition is as long as I is less than 10. But still this right here is going to execute. And notice it. When I go here, run our app, notice the value of I is 10. This is what I was talking about. So we first execute this code. The code that you put here in the do clause will be executed at least once. So at least once it will be executed, then it will check for the condition. Now, checking for the condition, if the condition is not true, so if this right here, if I is not less than 10, we will not execute this code again. But my point is that this code here will be executed at least once. So it will be executed at least once, and yeah, this is the difference between the do while and the while loop. Essentially, there is nothing hard for these loops. for these loops, that is. So we have the for loop, while, and do while loop. Again, while you are using the while loop, make sure that you add a condition that will evaluate eventually to be false. And you saw a moment ago what happens if you don't do that. The program will crash because this is an infinite loop, then it will never stop. And the same thing goes for the do while loop. For the for loop, the condition is within the body. So you type it like this for the variable that you declare, as long as that variable is lower than some value, increment it by 1, and repeat the code that's here. And using this lower or less than 10, here you are saying that this code is going to be executed 10 times. If you say 20, then the code here will be executed 20 times, 30, so on and so forth. Same goes here, while this, and here also while this. Let me just check here. I don't think that we used for loops. No, we did not use anywhere for loops in our previous project, but that's okay. We will use loops a lot in the projects that are upcoming. So this was it for loops and while loops and do while loops. Fahir here from awesomedudes.com, and I will see you in the next video.